Hello everyone, welcome to our online class. So in this class we will see problems on Green's theorem. Okay, so see the another problem in Green's theorem. Verify Green's theorem for circle integral C xy plus y squared dx plus x squared dy where C is bounded by y is equal to x and y is equal to x square. Correct. So what we have to do, first of all, see my given. So what is given here? Circle integral C xy plus y square into dx plus x square dy he gave here. So what we have to do? We have to compare given with Green's theorem. Compare with Green's theorem. So what is Green's theorem? Circle integral C m dx, circle integral C m dx plus n dy is equal double integral S dou n by dou x minus dou m by dou y into dx into dy. So this is Green's theorem statement, right? So what we have to do now, if I compare given with the Green's theorem, what I get here in place of m, we get m is equal to xy plus y square, and I get n is equal to how much ma? X square. So what we need dou m by dou y. So y is 1, I get x here, and y square will give you 2y. Then we need dou n by dou x ma. Dou n by dou x, x square differentiation is what? 2x, right? So therefore, we first of all what we did ma? We compare the given with the Green's theorem. We got the value of m and we got the value of n, right? Now you have to find the limits. What we have to find? We have to find the limits. How to find the limits here? See here, he gave two curves, no? Y is equal to x, y is equal to x, y is equal to x square. What is y is equal to x square ma? Y is equal to x square is a parabola, correct? Y is equal to x square is a parabola. Then y is equal to x is a straight line which is passing through origin. So this is what y is equal to x. So this point is O and this intersecting point is A ma. So this region you have to find, correct? This region you have to find. So that means first we have to go from O to A. We have to go from O to A. Then again we have to come back from A to O. O to A and A to O ma. So that means what we get here, what are the limits here? Y is equal to x square and y is equal to x, right? Y is equal to x and y is equal to x square. If I substitute y is equal to x here, x is equal to x square. So 0 is equal to x square minus x ma. 0 is equal to x, take common, x into x minus 1. So x is equal to 0, x is equal to 1. If x is equal to 0, what will be the y value? Y is also 0. If x is equal to 1, y also 1 ma. So this point is 1 comma 1 and here the point is origin 0 comma 0. That's it, very simple. So what we have to do first, compare given with the Green's theorem. So m, I got this value, this is our m, this is our m and this is our n. So then calculate dou n by dou x and dou m by dou y. Understand? So now I am solving right hand side of Green's theorem. So RHS is equal to double integral S dou n by dou x minus dou m by dou y into dx dy. That means this is equal, x is equal to x varies from 0 to 1. Here limits are x varies from 0 to 1 and y varies from, we are going first this curve, right? So then we are coming back A to O along straight line. So x square to x ma. Understand? So therefore x is equal to 0 to 1 and y is equal to x square to x dou n by dou x. Dou n by dou x is what? 2x minus dou m by dou y. That means minus x minus 2y ma into dx dy. Into dx dy. Clear? One second, let me get it down. So therefore this is equal to x is equal to 0 to 1, y is equal to 0 to, y is equal to x square to x. So what I get here, 2x minus x is x minus 2y into dx dy. So first integrate with respect to y. So x is equal to 0 to 1, x becomes xy, 2, y become y square by 2 ma. Limits are x square to x, dy is gone, dx is left. These 2 and 2 get cancelled. So x is equal to 0 to 1, substitute upper limit x, I get x square minus x square minus lower limit x square in place of y, x into x square x cube minus x power 4 into dx. So x square got cancel. X square got cancel. So minus x cube plus x power 4 integrate minus x power 4 by 4 minus into minus plus x power 4 integration x power 5 by 5. 0 to 1. Substitute upper limit 1, I get minus 1 by 4 plus 1 by 5. LCM is 20. 4, LCM is 20, no? So minus x cube plus x power 4 I am getting. So LCM is how much, ma? 20 minus 5 plus 4. So that will give you minus 1 by 20. This is the value of, which value? RHS. This is the value of RHS, ma. Understand? So we calculated the right side value minus 1 by 20. So this is the, if he ask you for 7 marks, that means half of the bit, then solve till here. If he ask you for verify, then you have to go for left hand side part also. Understand? So what we did here, first compare given with the Green's theorem, calculate m, take m and n, ma, then find dou n by dou x, dou m by dou y. So limits we calculated from here. So now we have to add this, we have to find this area. So this integration O to A, then A to O, O to A, then A to O. Okay, ma. So now to find LHS, LHS is equal to what? Integral O to A plus integral A to O. So first we find along OA, ma, along OA. That means this curve we are going. Y is equal to x square. This implies dy is equal to how much? 2x dx, and x is changing from 0 to 1. X is changing from 0 to 1. Okay. So substitute these all values, ma. Substitute these all values here. So therefore, circle integral C xy plus y square dx plus x square dy is equal to integral x is equal to 0 to 1. Means we are changing the full problem in terms of x. So y is equal to x square, x into x square x cube, then y square x power 4 into dx plus x square dy is how much, ma? 2x dx, right? So take out dx common. If I take dx common, x is equal to 0 to 1, x cube 2x cube 3x cube plus x power 4 into dx. So that means 3 into x cube integration x power 4 by 4, x power 4 integration x power 5 by 5, 0 to 1. So upper limit 1 in place of x, 3 by 4 plus 1 by 5 will give you 15 plus 4, 19 by 20. So this is the one value we got, 19 by 20. Now which one we have to find? Along AO, correct? Along OA is over, no? Now along AO we have to find. Little bit we move this side. So now here along AO, ma, along AO, which curve we are coming back from? A to O. A to O mein which curve it is? Y is equal to x, dy is equal to dx. Y is equal to x, dy is equal to what, ma? Dy is equal to dx. Clear? Dy is equal to dx. So therefore x is changing from 1 to 0. X we are coming from here to here, no? X is changing from 1 to 0. So substitute here. So this is equal to integral x is equal to 1 to 0. 1 to 0 in place of y we have to write x. So I get x square plus x square into dx plus x square dy is what? Dx. So take out dx common, ma. So dx we get 3x square dx. So this is equal to x is equal to 1 to 0, 3x square dx. That means 3x square dx means, so 3x square dx means, so what I get here, 3 into x square integration x cube by 3, limits are 1 to 0, 3 cancel, upper limit 0, lower limit minus 1, so I get minus 1, I got minus 1, ma. So therefore at the end what we have to do? At the end what we have to do, ma? We have to add. So LHS is equal to integral OA plus integral AO. That means 19 by 20 minus 1 will give you 19 minus 20 minus 1 by 20. So Green's theorem is verified. Green's theorem is verified. You have to write ma. Understand here? Very important problem and very simple problem also ma. Whenever he asks you